Hi, in this video, we're going to talk about wide area networks, the terminology and devices associated with WANs. Okay, so let's get started. So first of all, one of the primary differences between WANs and LANs is that within a local area network, we tend to think of a local area network as all the devices, all the links, wired, wireless, devices, you have control over everything. So in today's terminology, that's kind of what we think of as a local area network. You've got complete control. But with a wide area network, you actually subscribe to a service from the provider. And we'll take a look in some later videos what some of those services are. I introduced a few of those, things like Metro Ethernet, leased lines, old frame relay, although that kind of stuff is still around. But in this video, we're going to talk about basically just terminology and devices. So we've got equipment at both ends, both within the subscriber and also within the provider. All right, so let's start off with customer premises equipment. So also known as CPE. This is just all the equipment, all the devices, all the wiring that the customer has control over, that the customer owns, that's on their premises. Okay. Probably the only thing that they may not have control over is complete control over is something like maybe the cable junction box here and the actual connection coming in. There might be times actually where the provider might actually own we'll talk about this in a moment, but the DCE and even maybe the gateway router that connects to the provider. But in most cases, this is all your equipment, the DTE and the DCE. Okay, so that's customer premise equipment, CPE. Data communications equipment. Okay, this is sometimes known as, thought it was the DCE, but also sometimes known as circuit terminating equipment. This is the device that actually puts data on the local loop. It's what connects the subscriber's wide area network link to your network. This can also, there's something known as a CSU DSU that we'll talk more about here a little later. That is, let's make sure I don't have a picture. Yeah, I know, got coming up here. Okay, I want to make sure I had it coming up for you. But a CSU DSU. So this is actually the device that performs the interface between the DTE, the router in this case, and the local loop. So let me talk a little bit about this. This is an older DCE, CSU DSU device because it's connecting to a T1 circuit. But you can see that there's an interface there to T1 circuit and to the router. And by the way, we're going to talk more about T1s in a later video. Okay, so the CSU DSU provides the signal timing and the interface between the router and the circuit. Okay. And nowadays, in a lot of devices, instead of it being a separate device, in a lot of networks, I should say, instead of it being a separate device, it's actually integrated within, here I show a CSU DSU that's actually integrated in the T1 connection that goes inside the router. All right. Data terminal equipment, DTE. So this is the device that transmits the data between the customer and the wide area network. So this is really your interface to the DCE and the WAN service provider. Connects the DCE to inside your local area network. All right, the demarcation point. So this is the actual point at which it separates your network from the provider's network. So In this case, we have a maybe a cable coming in from the provider and a cable that's going from the router into, or the DCE device into the junction box. Okay, the local loop, also known as the last mile. So this is what connects you, your company, your CPE equipment, your LAN, your everything that you have control of, to the actual provider itself. The local loop, also known as the last mile, because it used to be kind of about a mile, that the central office back in the days of when everything connected through your telecom provider was about a mile. And it's the actual copper or fiber optic cable, can even be a wireless nowadays, that connects you to the central office, the local central office of your provider. Okay. As far as the central office goes, this is the service provider's facility or building that connects the customer premise equipment to the provider network. And by the way, there can be, depending on what this connection is, there might be something along the local loop. Like for DSL, you might see these things called a DSLAM that we'll talk about here in a moment. Okay, but it basically, what we're trying to do is connect from the CPE, from the subscribers network, to the local central office. And that's the local central office is what is then connected to the provider's network itself. And I'll talk more about what that looks like as far as the internet in a moment. Okay, so the toll network. Okay, so this is, in this case here, we're looking at the provider's network. This consists of a lot of different things. It consists of fiber optic and copper cabling, wireless, if need be, wireless communications. It consists of network operations center, routers, switches, etc. Let's see, over in the lower right here, we have a network operations center. Along here, I'm showing you a placard, a sign warning of that there's fiber optic cable underneath there along the railroad, which is actually quite common. You may know this, but Sprint actually stands for Southern Pacific Railway Internetwork. Southern Pacific Railway, they got into the telecom business, but because they have a right of way through long distances because of the railroad tracks. And that's why you see a lot of fiber optic cable laid along the railroad tracks. Okay, but this is the provider's network. Okay, that interconnects all of their subscribers and from either within short distances or long distances. Okay, some common WAN devices. Let's start up with some legacy stuff, the dial-up modems. There we have a old coupler modem there on the bottom, and looks like a Hayes modem there on top there. But this was definitely older technology. What modems did was they modulate the digital signal coming from the computers to an analog signal to go over the public switch telephone network. They would also demodulate the signal coming back initially. So when it went over the public switch telephone network, but we also have, let's see, I'm going to show these in a moment, but you see a DSL and cable modem, but we'll talk about those more in a moment. Let's see, the access server. So the access server is just the device that connected the multiple dial-up modems. So it was common back in the day when we used dial-up to connect to the internet. The homes would all have dial-up modems, and at different places within the internet service provider's network, they'd have these access servers, and that's basically where the dial-up modems terminated. Okay, now we have also these things called broadband modems. That's what I wanted to show down there. And this is a type of digital modem used with high-speed DSL or cable internet service. Okay. So both kind of operates under a similar manner. You're going to find both are much higher broadband frequencies and transmission speeds than the old dial-up modems. Cable modems are typically much faster than the DSL modems. And that just has to do with the using the coax cable that you usually connect to with your cable provider, as opposed to using the copper wire that connects the local loop to DSL subscribers, similar to what's used for your phone line. Okay, CSU, DSU. Okay, talked about that a little earlier, but this is what is used to connect your digital leased lines to your provider. Okay. Basically, I've mentioned this before, but used for termination of the digital signal, does things like error correction, it does some line monitoring, oh my gosh, I'm trying to remember all the things that we used to have to configure on these things. The nice thing that I'm kind of drawing a blank, it converts line frames into LAN to the signals and framing that the local area network can interpret. I will say that one of the things that was nice was when these were a separate box that connected to the router. It was one of those things that you had to learn how to configure that box separately. When it was integrated, the CSU, DSU, it was integrated within the router, within the interface. For example, with Cisco iOS, you could then do all your configuration under iOS commands for the DSU, CSU, DSU. All right, the router, of course. So that's where we actually provides the networking component. That's what really connects the customer premise equipment and your network to the rest of the wide area network provider and the internet. All right, within the service provider's cloud, okay, of course, they're going to have a variety of multi-layer switches and routers and various types of connections between them. Nowadays, it's a lot of fiber optic cable, but at times some wireless as well. Let's talk a little bit about two types of networks. The circuit switch network, and then we'll talk about the packet switch network. So the circuit switch network is what is really everything started with. I talked about this when we talked about dial-up modems and the phone and all that. But what would that circuit switch, let me kind of bring this up. It temporarily establishes a dedicated physical circuit for each communication session. So first of all, no communications happen until that connection was established. So what you would actually do is you dial a number, right? And what would happen is my grandmother did this, as a matter of fact. Some of this was done with an actual person having to patch you into whatever connection at the other end. So I won't go into that here, but there's some fascinating videos. If you ever just do on YouTube, look at, what was it, telephone operators, what was she called? But anyway, some great videos that show how this was done, even some training videos. They're wonderful. Anyway, you've got a physical circuit. So we'll talk about T1 lines in a later video, but you actually got part of a T1 line, a T1 channel. At one point, back in the day, you'd actually have a physical connection, the entire circuit. But whether it's a part of a channel of one circuit or a complete physical circuit, you had a circuit that was established. And you would dial here, would ring here, and they picked up the phone, and then that would then connect the entire circuit, and you had that circuit for as long as you wanted, whether you were talking or not, until one side hung up. You'd have that circuit. Now, the issue between one of the issues with circuit switch networks is the telephone company only built so many circuits. So they did not build a circuit so that everybody could be connected at the same time. What they tried to do was build enough circuits so that at peak hours, that the number of circuits internally could handle the number of people that needed a circuit. But if that exceeded if the number of people requiring a circuit exceeded the number of circuits that were available, then you get all circuits are busy, which is very common during the busiest day of the year for making a phone call, which was Mother's Day. All right. So anyway, two of the most common types of circuit switch technologies was the public switch telephone network, the landlines, and also ISDN used the circuit switch network. Okay, packet switching. So what packet switching does is it actually, instead of giving you an entire circuit where you can just transmit as much data, any size you want, what packet switching does is it actually divides the message into packets, which are then routed over a shared carrier network. So you're just like the roadway, you don't get that road when I leave my house to go to school. I don't get a lane reserved just for me. What I do is I share various roads with all the other cars. And that's basically what packet switching does. Matter of fact, AT&T did not bid on the first proposal for the ARPANET because they did circuit switching and they didn't think this whole new idea of packet switching would even work. Okay, so packet switching, there's a couple of approaches to packet switching, connectionless systems, and that's what we think of like IP. Between carrier networks, what's that? Gull addressing information must be carried. Oh, full, not gull. Full addressing information must be carried in each packet. Not sure what happened there. But yeah, you have to have kind of like an envelope. When you mail a letter, you have the source address and the destination address. So you need to have the address and information so the packet can reach its destination. Connection-oriented systems. So this is actually something that happens within the carrier network. We'll talk more about that a little later. But this includes things like MPLS today and older legacy technologies, frame relay and ATM. But they predetermine a route for a packet. And we'll see an example of that with MPLS. Okay. So packet switching costs a lot less than circuit switching because you can more efficiently send packets. You don't have to have enough circuits for everybody at the same time. However, you know, one thing about when I get in my car, there might be other cars on the road. In fact, there might be too many cars on the road on my way to school. So there might be some delays, and that's what we think of as latency and jitter. So the whole idea is that we do things that we have enough bandwidth, and when there isn't enough bandwidth and we need some kind of congestion control or quality of service, that's where quality of service comes in. Talk about that in later videos. But quality of service is like kind of like regulating the traffic before it even comes on the network. Can also think of it as like carpool lanes or form of quality of service. Those people get if there's two or more people in the car during certain peak hours, those certain lanes may be reserved for those people that are carpooling. Okay, so what does this look as far as the internet goes? Okay, as far as the internet, it's really just a connection of these different providers. Got I've got them labeled as internet service providers, can be also thought of as telecom service providers. But the links between them are the wide area networks. And it can also include sometimes the links within the provider's network itself. But usually when we think of wide area networks, we're thinking of the longer distances. But again, these might also, if we have Verizon or Quest, they're going to have wide area network links that are connecting their different IDFs, intermediate distribution facilities, or NOCs, or whatever they may be in the case, connecting their different service points. Okay, but we'll talk more about all this in later videos. Okay, so this is just an introduction to terminology and devices. A lot more to follow, a little introductory information, and we'll get into more details in later videos.